Docs, Google Sheets, and some other projects. Thanks. I pass it on to Arvind.
Thank you, Edgar. Hello, everyone. Um, Good evening, good day, good morning, from wherever you're joining. Thanks for joining. I'm Arvind, like I mentioned, and I have somewhere close to 17 years of software development and delivery experience. Um, so I had a good amount of consulting, and then had my own stint of startup for a while, and then joined back into consulting again. So yeah, I think we don't want to push it further, so maybe we'll start quickly.
Thanks, Erwin. Thanks, Edgar. So we will begin with this session. The session would be divided into two parts. So at first, we'll take up the presentation from our speakers and learn about Firestore a little more. In the second part, we would take up the question and answers. So I request Jaya would be sharing our Dory link in the chat section. You can post your questions, comments related to the talk or the subject on the Dory link, and we'll take them at the end of the session. So without much delay, I'll request Arvind to take over, and if you can start with the presentation.
Yeah, sure. I'll share my screen. Yeah, I presume it's visible to everyone.
Yes.
Welcome again. So Cloud Firestore, before we begin, I think we termed it as Startup World's Nitro, primarily for certain of its well-known benefits. It's going to give us a quick jump start to the problem and then start delivering and seeing your customers at the earliest. See, that's the core of this talk, and how Cloud Firestore is going to preferably take us there is the idea of this presentation, entire talk, right? Uh, Before we begin with actual Firestore, it comes from the Firebase family. Firebase, half a decade ago, it used to just be a messaging platform wherein it kind of transitively sends messages across devices, very high performant messaging platform. And Google acquired this, and it brought in a bigger, made it as a much more bigger family. Now Firebase has a lot of things apart from messaging. I think it has a beautiful store, a real-time DB as well. It provides authentication. You have a storage. You can host your application. You can run your backend service in terms of a Lambda function, even as a hosted application, and so on. So it's a whole suite of application for whichever business problem that you're trying to solve, be it a mobile application, be it a web app, or any kind of desktop application as well. You can just sync across and have all parts of the application linked in together using this Firebase family. So what is Firestore? Firestore is mostly a NoSQL store. That's how Google starts explaining it. But the bigger advantages are, rather than just being a NoSQL store, it becomes a bigger boon that it syncs across multiple devices, and the bigger advantage is it scales globally. Like, you can be in somewhere in Southeast Asia and connect to a server in California, and magically it will be closer to real time. So that's the bigger advantage of having Firestore. And let's see what happens in the older world. Like, usually when you want to launch an application or prepare your own solution, what we would be doing is we may have to firstly have a load balancer, prepare your solution, also the provisioning scripts, create your virtual machines, and then manage them, deploy your application using a CI/CD application, and then have your own provisioned database systems, of course with failover systems as well, and a replication if required for disaster recovery and so on. Now, this whole life cycle is kind of being challenged for the last 2, 3, 4 years. And now we have come to a place wherein, any startup or even any company, even if it's a corporate, which has to quickly take any application without burning the innovation, I think they started to question the first thing as, why should we even worry about provisioning all these things? Why can't we just write the code for the application and move on? So that's where the world used to be. Now, certain problems were here. First, let's talk about you may have to keep creating these missions. As when the scale increases, of course, you have auto scaling in multiple cloud providers, but still you may have to provision and write user data scripts for it, keep hardening the machines as and when a new patch release comes in. Again, keep managing your DB, take backup. Certain bit of it can be automated, but as and when a disaster comes in, you may have to fall in the pit of restoring it and bringing back everything well, right? So this is the usual life cycle that we had. Now, even in the application development process, we call this as layering. Actually, whenever, if you have worked on any enterprise platform, we usually start with an application with maybe a controller layer, action controllers, and then a service layer, and then the repository, and then finally you talk to the DB, right? There are too many advantages here, right? But if you want to take some application quickly just to validate a simple idea, I think that's kind of a burden to anybody who wants to hit the road, right? Now, there are some advantages like securities, or you can write a quick point cuts, action points anywhere, and then quickly wrap around some middlewares for the application. But still, your request has to transform. You have data transfer layers, you have JSON to the corresponding language object layers, and so on and so forth, right? Now, should we even take this pain of layering as such? So just to jot it down in a bigger flow of diagram, you have your mobile devices or all the user end applications. It goes through either a REST action endpoint or a GraphQL server, which is hosted in some place. And then you go to a service. It could be locally hosted or a remotely hosted service, or within the same application, it could be a simple instance of a service that's running. And then it talks to the ORM conversion layer, and then the domain layer, and finally your actual data, right? Now, you understand the problem with this. Like, even if you want to introduce a simple feature, you may have to go through this entire mundane process. Certain companies had taken some beautiful measures to come out of this by probably extracting out some generics out of it, of course, with the language support. But yes, still the problem of layering comes in. I'm not denying that this is a good approach because it helps in many places, but thinking from a purist standpoint of, hey, I want to know whether this application is going to be a market fit. I want to know whether this application is encouraged by people, right? From that perspective, this is kind of a digression that is being, honestly, that we'll have to take up. So what we mean by no backend servers, like if you don't have any of these VMs, if you think about it, GraphQL initially started with such a notion. I mean, when I read the GraphQL documentation, it felt as though that, hey, you know what? You just have to define your data and you just have to give a definition. That's it. That's more than enough. Now you can query based on the view can define what has to be obtained from the backend, right? Which is nice, but you still end up being provisioning your machine and hosting it as a service and so on, right? Which did not take away the real problem. Although it helped to a certain bit, but it did not, help in avoiding this entire layering being cut out, right? The other bigger problem is security, right? You still have to write, ignoring the role-based securities or authentication authorization, you still have to harden the machines for IP securities, VPN-based networks, and everything, right? You still have to take care of all those. What Firebase does is almost similar, but we don't provision any of those machines. We just do a Firebase deploy, that's it. And your machine is being containerized and being made available for you. I mean, I'm not talking only about the VMs here, even to an extent, Dockerization. These can come in at a super late time for a startup when it evolves into an enterprise, right? Not in the startup mode, or even not just for any startup company, but even a startup idea within a corporate, right? So let's not, how it's going to evolve into is something like this. From what if, this is the idea. So what if there is an SDK here and we are able to directly talk to the database? I mean, it sounds fun. I remember talking with some of my ex-colleagues that, why will someone directly access database? What happens to security? So there is a minimal security layer that's available, which we'll quickly look into. And before we jump on to the actuals, the nitty-gritties of Firestore, any application in this world, any user experience, there are majority of reads, like close to, beyond Pareto rules, it's close to 90-95% of reads, and less than 5 to 2% of writes that any application would contain, right? There are some good set of applications which could be 50-50, like let's say a trading app, because too many writes. It won't be exactly 50, but it will be slightly more than 10%, 20%. Still, reads are going to be higher. So now, why should we even design an system or architect a complete solution which is going to be performing really well for writes, but also it's going to be the similar architecture which is going to function for reads as well, right? Now, from that perspective, why can't we move to a situation where be view driven? Like that's going to improve a lot of user experience. Now, if you design your data structures, if you make it's going to be more view centric data structures, now it can scale transitively better. Now that's the idea behind any NoSQL store, right? I don't want to discuss too much about NoSQL SQL. We all know that NoSQL now started supporting transactions and SQL started supporting JSON. I'm pretty sure some days down the line, we are going to see a merger there. Like, I mean, nobody will be able to recognize whether it's a SQL or a NoSQL store, which I really hope that's a beautiful thing that could happen in the future. But yeah, let's not get into the discussion of which is good here. Then yes, I mean, this we spoke, like you don't want to write a scalable architecture wherein worry about all these pieces, which service should be scaled more, which one should not. It could be CPU footprint, it could be D layer. We don't want to worry about all those things, but make sure your data structure, like if you have a component in the UI, if you have a listing in the UI, make sure that your data structure directly represents that so that it's just a simple read and then display there, right? Now, that brings us to the next question, like, hey, you know what, NoSQL doesn't have a DB schema. I mean, we have a problem of missing out some properties, nullable properties. We cannot have any system to have everything to be nullable. I mean, that's insane, right? We don't want to do that. Instead, I mean, couple your application with some good amount of language, like TypeScript gives good control of defining your own classes, which you can stitch to the JSON data structure. You can definitely give optional fields there. I believe the same thing is there in POJOs for Java and POCOs for C#, and even in Python and other worlds, right? Similarly, you can also go ahead with some schema validators. As when you get a JSON structure, if you write plain mundane JavaScript or Python script or even Clojure script at the front end, which can be transpiled into any language, you still can do some validation on the obtained data and then still proceed to it. Now, the other question is, the DB is going to be exposed to everyone, right? I mean, that's intentionally done that way, but you can change it. Like you can say, I don't want to expose everything to public as a rule. Now, this rule engine is beautifully built wherein you can say as a hierarchy, okay, stop everything, maybe allow only read to this particular table or a collection, and allow only a specific user to read a particular set of collection. And this works insane. And I can assure you, we have released certain bit of applications which we see that it's working at the right levels. The second good example is you can lock at any levels, right? Based on the request payload. I'm talking about HTTP request here. Based on the request token, you can still use the same things in your security layer and stop it, right? See, that's the beauty of security layer. A quick example here. So this is how it looks. By default, these roles won't be here. You have to include, say that, hey, I don't want to give any access to anybody, right? And second thing is, maybe, you know what, there is a simple function I want to define in which if anybody wants to read the orders here, right, they should be able to access only their orders. So how we identify the current user is, again, we have a different collection or a table which says from the request token email, give me whether this user is already present or not. Now, using that user ID, you can check whatever is the user ID that comes into the request payload. Now, that's how we verify that, hey, you know what, this is the right data set or rows to be, or documents to be shown to the corresponding users. There are beautiful documentation available. I don't want this to be a discussion only on security rules. So moving ahead. So without further delay, I think we'll have a quick look up into a demo here. So I have a simple CRA, create React app application. Don't worry about whether you know React or you're not aware of any of the syntax here. You will be able to follow it along the lines. And the first thing is we have Firebase CLI being provided. And this is a beautiful CLI. You can control anything, everything from this, starting from your hosting, all the Firebase functionalities provided by Firebase platform, right? So Firebase, you don't need to always connect to a remote database. Firebase provides an emulator suite as well, so that you can actually initialize emulators here using this command. With this, it's going to ask you what are all the emulators that you need. Like I need Firestore or authentication, storage. You can choose any kind of things here. Right now, we are worried only about Firestore and maybe hosting. Hosting anyway, I'm not going to use. I'm just adding it here. So now we added this. Yes, download this. I've already downloaded it, so it's cached and it's available. So this automatically writes certain bit of information into our code repo. This you can check in and share across your other devs as well. Just a quick look into the Firestore JS. So this configuration is something that you will automatically get. So you don't need to invent it. This will be available as and when you initiate a project in Firestore. You just have to copy and paste it here. I just moved some of it into a different JSON file just for not exposing some details. Then a simple line here will say, okay, I want to connect this Firestore to my local host, which is running in 8080, right? That's it. So now I can just say Firebase emulators start. So this will start all the emulators that we initialize, right? Yep. So we have Firestore running. I've got only Firestore and hosting to be running. We didn't configure hosting, so it'll anyway fail. Let's not worry about it. So how the emulator looks like is something like this. So you will have a way, a place to start a collection. Collection is equivalent to tables in SQL world, and you can keep creating any number of documents and so on, right? Let's maybe before creating anything here, let's go ahead to the world-renowned application which we are going to build now. It's going to be a super important application, a to-do application. I mean, although it's funny, to-do is kind of cute because it has the CRUD available everywhere. Like you can update, create, delete, and it provides the entire suite for validating anything and everything, right? So quickly, this returns just a simple snippet of HTML here, which is rendered here. Yeah, I mean, I did spend some time to figure out how to make this all blue, but yeah. I'm just going to create a to-do component here. Creating a component is just a simple function. React. So I'm going to return this here, probably with the title saying to-do items. First thing we want to do is we just need an input field. Don't worry about the CSS styling and all the other stuff. You can think me as a vintage HTML developer. So I mean, I believe that would satisfy what we are trying to do here, right? So we first have to create a variable in React that, hey, you know what? I want to use a to-do text that has to be added as a to-do, right? And as and when any change happens, let's save it into, right? Let's just save it into this particular to-do text as and when the change happens. So how we create these here are to-do text and set to-do text. Just a simple use state is enough. I'll just assign a default blank value here. So before that, I would like to start the application as well. So we already have the emulator running, and right now we haven't connected anything to our Firestore, right? This is just going to show us some text box, nothing else, right? As when you type, it gets added to the state and nothing else. Now, the second part is when you hit enter, let's say on key down probably, or key up as and when we come out. So maybe we'll just say add to do, right? We just want to send it to Firestore and add to, which will take a text. So we already have the text in our global variable here as a to-do text. So how to add this to Firestore by default? So you have to import Firestore library here, which is Firebase Firestore, and add doc is the, we're going to add a simple document into a particular collection. So when you say collection, just start typing collection, and same collection is again available in the same package. And we just have to give a reference to the emulator here, right? So you can think of this as a connection object that we use to create for any SQL store or any other application, which we already created using this Firestore.js, right? We are just exporting this DB object here. I'm just going to reuse the same thing here. Import. So first pass the instance of it. Now I need to have a collection called to-dos, and I'm going to create a new document called a to-do document, which will have these properties. So firstly, we'll have a to-do text. So any to-do should have whether it is done or not. By default, it's not done, so we'll just say false. And the third is, let's say, who added this? Probably I'll hard code it for now because we don't have any users as such, right? Now this is available here. You can see there are no collections being created and so on. I'm just going to add a to-do, maybe buy groceries. I hit enter, and yeah, I should have cleared this, but let's come back to that later. Now, if you see, we have so many things being added here because of a mistake I did. This ideally should consider the event here, right? So only in case of only if the user press enter, let's do all these stuff, right? Otherwise, let it be. And then finally, we'll just say blank, right? Yeah, that's a good mistake to make. Now we'll take buy groceries. Now we have this object automatically created. It created the collection. It established everything and so on. Now you can modify the is done directly here just because it's an emulator and direct access to DB here. Let's also list down all the to-dos that are being added. So use effect is React like cycle. You can think this as an on start, what should happen in this application, right? As and when this to-do function is called, what should be the lifecycle thing? So by default, it should go and fetch to-dos, right? So we'll just write this fetch to-dos quickly here. Let me just check the time. Yeah, I have time. So all you have to do is, so similar to add doc, we are just going to get docs, right? Similarly, you just have to pass the same collection reference here with passing the connection object and the to-dos, right? Once that's available, you will get something called a snapshot. All you have to do is set the to-dos into this. So we don't have this to-dos right now. We'll create the to-do array. It's going to be an array of to-dos here, right? So I'm not creating any limits on the to-dos just because it's a demo application. Use state. So it's a default empty array. And at first, it will just read everything from the snapshot. I'm going to read all the documents, not worrying about whatever changed here. D.data. Data will give you only the second part in this, right? So, but there are some identifiers also to this document. We probably might need this to do an update into the application, right? So I'll probably introduce the ID also here, which we get from the snapshot, right? So now let's go back here and refresh. Nothing happens because we didn't write any code to render them. So we'll just create probably a different container here, which will print the to-dos one by one. To-do here, right? So firstly, you need a checkbox, right? Whether it's done or not, just to show you the marker. And then you need what happens after this, right? So let's say update to do, right? And finally, you need to show whether it is, I mean, the actual value is not printed here. I just print that from to-do dot is done. That's a variable that's going to get us the values. So to this update to do, we may have to pass which is the item that we are modifying here. So we'll just take the identifier of this and the existing status of this, right? You can do a done and undone status on the to-do as well, right? And finally, we would also have a simple untie here, probably to-do dot text, right? That's the text that we are going to get. I'll quickly declare this function so that we can quickly view the list of. Right? Yeah. So by default, it loads all the groceries. You click on this, nothing happens, mainly because we haven't done anything. So similar to add to do the same convention, we just follow update doc, right? Similar to add doc, get docs, update doc. The only difference is now we are going to update only a specific document here. So we use, instead of collection, we are going to use the document reference, which we will import from here. The convention is the same. Pass the connection, pass the collection name, and the identifier that we obtained. I pass the ID and the existing resident state here. So probably this is the ID. And as and when you want to update, you may have to pass what field has to be updated here, right? So I want to update the inversion of the previous state, right? So that's it. It's all done. Now, if you think about it, after updating, we may want to know the updated status here in the document, right? Because if you just click on this, it still executes as done, but we don't see the later data here. So what I'm going to do is I'm just going to say fetch docs again, right? I will come back to this. There are some updates that we'll do. Now, as and when you make a change, you're going to see the updated values quickly here, right? You can keep adding something, read a book, right? So now after adding a document also, probably we may have to do the same thing, right? So just a moment. I'll just say fetch tools again here. Now write a blog and so on, right? So now it quickly updates and gives you all the results, right? You can keep changing, you get the latest update. Now the problem happens when you have a different device. Let's say there is another browser here, the same user, right? I spoke about all this syncing across devices and so on. And I mean, we just have to see what's happening here, right? So when I mark done here, it should get reflected automatically here, which is not happening. Primarily because we have written it in such a way that application should always get the document on load, and beyond that, we don't do any change at all, right? So what we are going to do is it's a very simple change. If you want to get a real-time update, what you have to do is you just have to write some 230 lines of WebSocket code. I mean, writing 230 lines should not take much of a time. So we just have to create that WebSocket code and link it here. Or the other approach is use the on snapshot callback that's provided by Firestore itself, right? So if you do this, what actually happens is instead of get documents, I just want to know what is the snapshot of this particular collection as and when it changes. There is a slight change in syntax here. You just have to give a callback as and when the snapshot changes, this callback will get called. So we can just print what's happening to this document via this doc changes. And then we'll save this. Now, if you also notice, anyway, it's going to get us all the snapshots real time, right? So we don't need to repeatedly get this fetch to dos every time we do something, right? So I'm going to just quickly remove all those fetch to dos as and when we make any change in the document, right? So look at this. You're going to always get it. And if you read the doc changes here, I'm sorry, I think I should in the object here. If you see the document change here, you will notice I have a modified event, and the document also will be given here, which document got modified. And you can also do with others, and you will get another update here as an added state, right? And so on. Now with this, if you open another tab, right, and the magic happens. That's it. So with this, I mean, I'm connecting to an emulator which is running in my machine, so it doesn't do any network call and so on. It won't be this. You will still see somewhere around 70 to 200 seconds delay, depending on your network connection. I mean, we'll be able to guarantee this, but it's closer to real time. You will be able to get the updates on these things. More on snapshots later in the presentation. So yeah, pretty much we built a quick to-do application wherein we add, update, and look at the updates every time there, right? One thing which I missed to show you is what are all the rules that we have built here, right? The security rules. If you look at this, I'm allowing read and write for everyone here. Don't do this. This is just for our purpose. Maybe we don't have any authentication built around here, right? If at all we build the authentication layer here, we can just stitch in the corresponding things here and make sure only the corresponding user will be able to modify their own to-dos, right? That's a very simple change that could be done. Even if they want to pass a different constraint, the Firestore rules will take care of restricting those documents from being read across. Right. That's it with the demo. And I'm going back to the slides. Yes, to-do is just one single document update, right? We didn't, I mean, showcasing a to-do, talking about Firestore is not doing justice to it. If you think about it, we need transactions. We are going to modify multiple documents. We are going to modify, we need to make sure that it's all atomic and people are going to wait for their change to be updated, right? So these are already available in Firestore. Talking about how the traditional locking happens, the pessimistic locking, wherein every user have to wait their own time. Only after the previous user completes, the next user will be processed if they are contending on the exact similar rows. And it changes between multiple database systems. Some systems locks the entire table. Some system does a row level lock. I believe 2022, everyone is towards row level locks now, right? This is good, but think about some problems. Like if you want to lock from a client, considering that we are going to do it in mobile application or web application, you don't want to lock the document and be disconnected, right? Now you will be facing a problem of connection timeout, right? Every other person has to either wait for this connection to timeout unless they want to perform some operation, which is bad experience. And you can reduce this connection timeout to a lower number also, because that would again spoil the connection. Multiple times you may have to connect to it, right? So unnecessarily you will keep pulling a new set of connections. So that's a two-side problem. So how Firestore solved it is using a different approach called an optimistic locking. What it does is there are no locks in the system. How it does is you just have to follow a simple convention, which is as and when you start a transaction, you begin a transaction, you just have to read all the documents that you want to modify or you want to utilize in modifying certain documents. Read everything at the start, do your changes, and finally do the write back, right? So what Firestore internally does is it will just do a check and write. So it will compare whatever was read at the start, was it the same state at the end? If it's going to be the same state, it allows you to write and you win the transaction lock and you will release it after that. If not, it's going to retry. And it's going to retry multiple times. There is no exact number of times it's going to retry. And that's decided by the Firestore retry algorithm. We have seen somewhere between 15 to 25 number of retries it does. And it's not an exponential back off that's going to be, because that again doesn't answer the user experience. It's going to be immediate. It will just keep blasting Firestore, right? Now, this happens on the client libraries by default. If you go to the server libraries, since you are much closer to Firestore instances and it's going to run within a cloud function or a Lambda function, you can still take the call of connection timeouts and pessimistic lock, right? So what happens if a user loses the connection or if the transaction fails for a user, right? See, anyway, the user is going to retry, right? If I am not able to book my train tickets and it shows, hey, some error happened, we're just going to click the submit button again, right? So this is exactly what Firestore does for it, which is a beautiful thing from an engineering perspective, right? And the other usual pitfall that we have noticed when we write transactions is, although it updates document, it also does a document merge. So if you look into our example here, we did not write the entire document when we updated, right? We just modified one single property. So it kind of transitively merged the change without touching any of the other properties. Don't do this when you do a transaction because it defeats the purpose of transaction there. Avoid this. Yeah, I mean, you can still do this, but you will definitely figure this out when you hit your first production release. It's going to be on your face there, right? So, and the second thing is, do not do any quick aggregation or a common document being written by all the transactions, right? Make sure your data structure is designed in some way that you write user-specific documents. Maybe if it's a global document, put it behind a trigger, like a create, update, or delete trigger, and handle it that way. Snapshot magic. Yeah, of course, this is a wonderful real-time update that's being sent across. But if you think about it, you should not go crazy about this, right? You don't want to do snapshot for whatever queries that we write. Your application will definitely be defeated in performance because all the updates is going to come to you. Make sure you put it at the right places, and make sure the snapshotted document that's going to be received is thinner meaning lesser number of properties. So that way it scales much better. So yeah, the only thing you have to worry about is the data structure here, right? Yes, just a quick recap. We get to focus only on the business now. I mean, I didn't do any code related to Firestore provisioning and sort. You just import, copy paste the Firebase configuration code, start coding, right? We just did that. So similar to less code, less bugs, you don't have to worry about the vulnerabilities that's going to come in with the higher infrastructure that's going to come, right? So yeah. And yes, performance. This is a really important thing to worry about. By scale, right? By time you're going to hit a scale where you don't know how big Firestore is going to is capable of performing, right? The surface area of Firestore is much larger. So like I mentioned at the start, you will get to hit your service deployed in California from India. They have proper persistent offline replication available all over, and it's transitively working together even during the transaction cycles. So that's good about it. And architecturally, although it's a complete black box for us, we could see the effect of how it works. The second thing is, when talking about performance, of course, concurrency comes into place. Now, if you are going to fight for creating some concurrent document, make sure that you write idempotent code. Even, I mean, right now, the document identifiers, whatever we created, are auto-generated. Usually go for some business identifiers. Let the business define how this ID should be framed so that no conflicting document would be created. One of them wins, the other one will be said, hey, you know what, the document already exists. Make sure that you follow it. It's something similar to the primary key constraints that we have in RDBM as well, right? And then make sure you don't scan the entire, don't sweep the entire Firestore because your pricing is dependent on the number of documents that you're going to process, right? I'll talk about that later. Although initially when I read this statement that pricing relies on the number of reads, it's not that skeptical or something that we have to really worry about. That's meager. And don't mix too much of constraints in a query. Same rule. Figure out the right data structure for your views. Always view, be view driven. It's okay to replicate. See, that's the power of NoSQL, right? So, of course, there are some hurdles that you will face, but yeah, make sure that you find the right balance between where to stop and where to keep duplicating and so on. And talking about performance, one important tool that's going to help you is the key visualizer. See, this helps you to view a complete heat map of what's happening to a document. So if you look at this example here, this is taken from a production database that we delivered with close to 1 million users. So now, the lighter the color, that particular document is being hit by a lot of users, right? Now you can query and see which particular start and key is that, and maybe take a step back, go to your drawing board and think about how to restructure this. And this is a very powerful tool. By time you will face it. Initially, you may not get a glaring thing. Maybe you can lotus this to generate the beautiful view like this and then start working towards the data structure as such. Of course, no tool is like a silver bullet. Everything has its own limitations. The first thing, which is kind of a bummer that we faced, was you cannot have multiple array contains. I mean, you can have multiple where clauses, but you cannot have multiple array contains here, right? So it's designed in some way. I mean, probably this is going to come in future, but it's designed in some way that there is something wrong with the data structure. Probably you may have to hierarchically store the data. Like if it's an athlete, maybe put the season first, season 2022, and then the athletes, season 2021, and then the athletes. See, that way you have solved the other problem automatically, and you will not face this problem at all. Or do the older map reduce way, like take the batches, process one by one chunk, and do the second, first, second array contains can be done with reduce function. Hierarchical structuring cannot work always, but probably this map reduce can help in some places, right? Nobody would want to write it on the request cycle. Usually happens in some kind of a batch job or a scheduled job, right? Yeah, the second bigger thing is there are no aggregations. 2 days back in the Firestore conference, they released the count being included. But this no aggregation is not that big a pain if you think about it, because this is not an store that we are going to use for anything and everything. It's not. Think it as user-specific application, right? And it serves that purpose. So we'll be able to utilize it at that at that level in the right way. If you want to do a better aggregation, there are multiple other tools, which I'll talk about quickly. And do a good amount of testing on the security rules. Although we have the rules defined as a rule set, it's better to write some quick tests to see running in the CI or CD to say, oh, I'm not able to access this, I'm able to access this, and so on. So it helps you in the long run. Data structure, keep looking at this, key visualizers, look how the functionality changes in the view, restructure in the same way, right? Pricing is directly proportional to scale. See, this is a blessing in disguise. Initially, if you don't have that of a scale, you don't really pay anything at all. It's like if you don't run anything, you don't pay anything, right? In that front, there is no minimal charges there. And if you come to a considerable scale, and then it falls out, right? So it's not going to be too pricey, but yeah, I'm not here as a Firestore pricing advocate. It's a separate company. So until from our experience, we did not see that glaring a pricing as such. So where to not use, like there is no aggregation. So the right answer is no analytical processing here. You don't want to write it on reports from here. So, but you can actually port data as and when it changes, as and when some data modifies, or you can write some simple schedulers to batch wise, write it into BigQuery, which is a proper SQL store. You can do whatever, you can go crazy there. And always remember, this has to face the user. You don't want to use it for some internal report generation, PDF generation kind of tools as such. And some handy tools that we had until now on Firestore is the firstly is the Firecode Traverser. I would recommend this a lot because it helped us into batch. Just like how we query, you can just give it a query and it can batch us into the number of limits specified, and you can write your business logic there. It's a wonderful tool. The second thing is the Firefoo, which is, according to us, it's the right UI because you get to access data. You can correlate somewhat closer to pgadmin, but one good advantage is you can keep writing some scripts within the same UI for against your DB, and you don't want to write a complete different script anywhere to do any processing or understand the DB. Fugo is a wonderful tool for CLI, right? You don't want to open a UI, or you don't want to connect. If you just have CLI access, you can just directly connect to your Firebase directly using Figo, and you can get your pre-printed JSON structure back. You can write better queries there as well. And one extension that's going to help you in the long run is the one that's going to port to BigQuery, and this is going to help you in writing proper analytical queries from BigQuery as such. And Firestore has a wonderful documentation. Follow that. It keeps on changing as and when a new release comes out. But rely on that. There are numerous number of blogs that have been written. Use the right set of libraries, and yeah, start delivering. So thank you very much. This is the overall glimpse that we were able to give you. Thank you very much. I'm just handing over it to Bhavneet, Edgar, and Jaya for questions.
Sure, Arvind. Thank you so much for that wonderful presentation and the great demo. And as I thank you, I'll also simultaneously move to my question and answer session, sharing my Dory screen. We have a couple of questions. So moving on to the first question, there's an anonymous question from someone saying how to maintain the consistency of the duplicated data.
I can take this one as much as my voice permits. So this is a problem with NoSQL databases in general, right? This is not just a problem with Firestore, and there are some approaches, or there's a range of approaches that you can take for this. First of all, you can go the SQL or the relational database way, right? So you can create multiple documents and reference them by IDs. Then your code would have to trigger multiple requests and build your data in your client, which is it solves duplication, but of course it would generate more requests. And then you can go all the way down the other path, which is just don't care about duplicated data and provide eventual consistency, right? You can have a batch process that every 10 minutes it takes care of consistency. And of course, this is going the completely denormalized route, right? Which is something similar to what you would do with something completely denormalized like Bigtable. So anywhere in between those two are fine, depending on your use case, of course. The good thing about, or the thing I like about NoSQL databases is that they give you a lot of options, and you have to be careful as well how to model your data. So one thing that is to take away from any time you work with NoSQL databases is be sure to think about how you structure your data, and you need to build your schemas properly, even when there's no real schema. But you need to design your data, and you need to set your application around your data. So yeah, hopefully that answers Coffee Monkey's question.
Thank you, Edgar. So Paul is asking, how easy is it to integrate the Firestore to the front end hosted on AWS?
I think Arvind demonstrated a little bit of that in his demo. With Firestore, all you need to do is worry about your clients. So really, where the server is hosted is not necessarily a factor. So although there is a server SDK as well, but one of the nicest things I think about Firestore and Firebase in general is that integration is just importing the SDK, figuring out authentication, and then you're ready to go.
Great. Anurag has a question asking how Snapshot internally worked. Is it using WebSocket or some other protocol?
As far as I understand, it uses WebSockets, yeah.
Yeah, it uses WebSockets. That's right.
Okay.
You don't have to deal with them though, which is the nice part.
I think that, sorry, I chime in. I think it uses long polling. Yeah, that.
Thanks, Pablo.
Sure. What are best practices to follow while structuring our data into Cloud Firestore?
There are a number of those that are really well documented in Firestore's tutorials and documentation. One of the things that they recommend is that first of all, you need to think about your data and you think about your problem. Do you want to go to a more denormalized schema or something more normalized? There's also, when you build your IDs, I think Arvind mentioned that you can customize your IDs for your documents. One thing that Firestore recommends, or that they're very, very adamant about, is that you do not create IDs that are monotonically increasing. So you don't use user 1, user 2, user 3, because of the way Firestore scatters the data. That will create hotspots or machines that are constantly queried, right? So all your requests will fall in the same place. So you want to have IDs that are very scattered. And there's a few other best practices in terms of that apply also to every NoSQL. And again, I think that, like I said earlier, the beauty of all this is that you have a lot of option, and you have to be mindful when you structure your data. Arvin also mentioned these libraries are going to give you JSON structures. Always put a layer in the middle so you can apply types, or you can have your own data structures in your language that are not just plain blobs of untyped JSON data. You can validate your schema as well. So those are, I don't know if Arvin, you have any other ones, but those are the ones that I think are top of my head.
Yeah. I mean, one thing, I mean, all the above for what Edgar mentioned. But one thing I would add on is probably your problem plus the view that you want to give to the users, right? See, that should dictate the data structure. Like, I mean, we are finally doing it. But even if you want to change the view to something else drastically, it's not going to change the complete data structure there, right? So ideally, you're like similar to domain driven, it will be view driven most of the times. But yes, you don't want to put a user data into somewhere else, right? So mostly the co-located data can be put together and probably allow certain things to be shown only on the view driven. So that actually dictated a lot of things to be in the right places. By time you will know whether we should denormalize, have a different collection to hold certain data, maybe have an array within the same document to put a list of identifiers, and so on. But I would say there is no prepared set of answers here. You may have to first start designing it and then face the problem and then restructure it. That's the approach, rather than keeping yourself prepared for a particular solution as such.
All right. Nilesh is asking, can we integrate the Firestore with an existing app? Does it play well with the existing features and APIs?
I'm not sure that I understand 100% the question. I think that I would say yes. Of course, if you have an application that's already built on top of a database, I don't know if you would like to go ahead and migrate your whole database, but yeah, you can create new features of your application using Firestore if you want to. And there's a number of third-party libraries and APIs that also integrate with other libraries. But yeah, I would say absolutely yes.
Okay. So this wraps our questions that are posted on Dory. Do we have any live questions here? All right, then we are well in time. Arvind and Edgar, do you want to share some notes or any inputs from your end that you're asked?
Nothing specifically for me. I just I would suggest, I would recommend everyone who wants to go on with and keep looking into this to go. There's a lot of very, very good documentation on Firebase, on Firestore. There's a lot of very good tutorials that are provided by Google as well. There's a lot of tools as well. So I would say have fun, and it's actually, if you're moving from SQL or from SQL world, this is a bit daunting at the beginning. At least it took me a while to get used to NoSQL world, but it's a really interesting topic as well. So I recommend everyone to go ahead and do that.
Great. Thank you so much, everyone, for joining in. You were the wonderful audience. Thank you, Edgar and Arvind, for the great session. We look forward to next talks that we would conduct. Till then, everyone, please take care and have a good time. Thank you so much.
Thank you.
Thank you, everyone.
Bye-bye.